Hello everyone, this is Venugopal. Today I will give you a demo lecture on this topic of law of conservation of mechanical energy. So before studying about this law of conservation of mechanical energy, first of all, what is the mechanical energy? So what is the mechanical energy? Mechanical energy is nothing but the sum of the kinetic energy and potential energy. So mechanical energy is equal to kinetic energy plus potential energy. So this one only we can write E equal to K plus U. Okay. So the sum of the kinetic energy and potential energy is called as a mechanical energy. Okay. So what is the law of conservation of mechanical energy? So law of conservation of mechanical energy means in any conservative system, at any point, this mechanical energy is the constant. Okay, so that means in any conservative system, at any point, the sum of this kinetic energy and potential energy is the same. Of course, individually, this kinetic energy and potential energy may or may not be changes. Individually, there will be changes, but the sum of this kinetic energy and potential energy will be not change. Okay, so that means the kinetic energy will be transformed into potential energy, or this potential energy will be transformed into kinetic energy. So it will be either decrease or increase, and it will be also either decrease or increase, but the sum will be not change. The mechanical energy will be not change. So it is always same at any point. Okay. So this is the law of conservation of mechanical energy. For example, I am taking the one object which is present in the ground. So initially this object is I am throwing in upward direction. Then what will be happen? It will be moved, it will be reaches to certain height, and after reaching to certain height, again it will be come back to the earth. Okay, again it will be come back to the ground only. So here when it is in the ground state, when the object is present in the ground state, it has only kinetic energy. So according to formula, kinetic energy is equal to half mv square. So initially it has some amount of the velocity. So because of that velocity, it has some amount of the kinetic energy. But initially in the ground state, this object doesn't have any potential energy, because here the h value is equal to 0. So according to formula PE equal to mgh, this potential energy is equal to 0 in the ground state. Okay. So in the ground state, it has only kinetic energy. There is no potential energy. So this kinetic energy will be maximum kinetic energy. Okay. So now when this object is moving in the upward direction, this object is moving in the upward direction, the height will be decreases. Okay, so the height will be decreases from the ground. So the height is decreasing. So according to this formula, it will be gets the potential energy. So the potential energy of the object will be increases. When the height will be increases, potential energy will be increases. Okay, and at the same time, when it will be move in the upward direction, its velocity will be slowly decreases. So this object velocity will be slowly decreases. Because of that, this velocity is decreasing. So kinetic energy of the object will be decreases. Okay. So when the object is moving in the upward direction, potential energy is increases and kinetic energy will be decreases. Okay. So how much amount of the kinetic energy will be decreased? Same amount of the energy will be increased in the form of the potential energy. That means this kinetic energy is converted into the potential energy of the object. So here energy will be not created and the energy will be not destroyed. The energy will be transformed from one form to another form. Okay, so the energy is transformed from kinetic energy to potential energy when it will be moved in the upward direction. Okay, so now when the object is present here, okay, so that means, for example, I am taking this is the point. So at this point, the potential energy will be increases and same amount of the kinetic energy will be decreases. So the sum of the kinetic energy and potential energy is the same. Okay. So how much amount of the mechanical energy is present at the ground state? Same amount of the mechanical energy will be present at this point. You take this point also. You take any point here. So at this point is also the sum of this potential energy and kinetic energy is the same. You take another any one point. It is the same. Okay. So now you take maximum height. Okay. At maximum height, then what will be happen? Its velocity will be decreases to zero value. Okay. The total velocity of the object, the total velocity of the object will be becomes zero. So because of that, again it will be come back to the earth. Okay. So when this velocity will become zero, the kinetic energy will become zero. Okay. And at this point, this object has the maximum height from the ground. Okay. So it has the maximum height. So the potential energy it has the some value. So this potential energy is the maximum. Okay. At maximum height, the potential energy of the object is the maximum because it reaches to maximum height. The object will be reaches to maximum height. So at this point, kinetic energy is zero and potential energy is the maximum. And at this point, potential energy is zero, kinetic energy is the maximum. So when we will see these 2 points, when we will observe these 2 points, the total kinetic energy is converted into the potential energy when the object will be reaches from here to here. Okay. So the total kinetic energy is converted into the potential energy. But the sum of the potential energy and kinetic energy is the again same. At this point and this point, the sum of the kinetic energy and potential energy is the same. It will be not changes. It is always constant. So, how much mechanical energy is present here? Same amount of the mechanical energy is present here also. Okay. So, same case will be happen when it will be come back to the ground also. So, at this point, what will be happen? Again, the velocity of the object increases. Okay. So, the kinetic energy will be increases. And height of the object will be decreases, so the potential energy will be decreases. Okay. So potential energy decreases, kinetic energy increases. So how much amount of the potential energy decreases, same amount of the energy will be increases in the form of kinetic energy. Okay. So because of that, the sum of the kinetic energy and potential energy is the same. Okay. So this is the law of conservation of mechanical energy. Okay. So now we will see some numericals on this topic. Okay. For example, suppose I am taking the one object is moving in a circular path. So at this point, the object is the present at the initial position of the object, and this is the final position of the object, and this object is tied to a rope. Okay. So because of that, some amount of the tension will be present in this rope. Okay. So now, what will be the tension? What will be the tension of the string at the bottom? Okay. What will be the tension of the string at the bottom when the tension at the top is zero? Okay. So what is the tension of the string at the bottom when the tension of the string at the top is 0? So the tension at this point, the tension at the top is equal to 0, and what is the tension at the bottom? Okay. So now here, before finding this tension of the string at the bottom, first of all, we have to take the free body diagrams when the object is present at initial position and when the object is present at final position. Okay. So if you want to take this is the initial position or this is the final position, it is not a problem. Okay. So now here, initially, for example, at the top, what is the free body diagram? So at the top position, the object is present here. So on the object, what is the free body diagram of the object? So the tension is acting in the downward direction. So the tension will be acts in the downward direction, and the gravitational force will be also acts in the downward direction. So the gravitational force is acting in the downward direction, and the centrifugal force will be acts in upward direction. Okay, so the centrifugal force will be acts in upward direction. So if any object is tied to rope or any string, the centripetal force the centripetal force will be acts in the downward direction towards the center of the circle, and same amount of the force will be act in opposite direction. That means away of the object, away from the center of the object, the centrifugal force will be also acts to balance this centripetal force. Okay, to balance this centripetal force, the centrifugal force will be acts in opposite direction. Okay, so that is away from the object. Okay, so in this direction the centrifugal force will be also acts. So this is the centrifugal force and tension force and the gravitational force. Then what are the total amount of the forces? So that is, we can write this is T plus mg is equal to centrifugal force, and this is the tension at the top. So to identify easily, I am representing tension at the top. And already we know the tension at the top is 0. So we can write mg. The tension at the top is equal to 0. So 0 plus mg equal to the centrifugal force. Already we know it has the some formula, that is the mv square by r. Okay. So here mv square by r. If I will take this r is the radius of the circle. Okay. So the radius of the circle is I am representing with the r. So I can write mv square by r. Okay. So now here this mm will be cancelled. So we can write v square is equal to r into g. Okay. So this is the you can take first equation. Okay. And next, when the object is at the bottom, what are the free body diagram? What is the free body diagram? So when the object is at the bottom, now, so in which direction the tensional force will be acts? So the rope is here, the tension string is the present here. So the tension force will be always acts in away from the object. So the tension force will be acts in this direction. So the tension at the bottom in upward direction. Okay, and the gravitational force will be also acts in the downward direction, mg. And again here is also the centrifugal force will be acts. Okay, so that centrifugal force will be acts in the downward direction. Okay, so always when the object will be moving a circular path, always at every point in the circular path the centrifugal force will be acts away from the center of the circle. Okay, the centripetal force will be acts towards the center of the circle. Okay, so here the centrifugal force will be acts. So in this direction, the centrifugal force will be acts. Okay. So now what is the total forces? So now here this is the TB equal to FC plus mg. Okay. So now what is the FC? Centrifugal force, that is the mv square by r plus mg. Okay. So now this is the tensional force at the bottom. These tensional force we have to calculate. Okay. So to find out this tensional force, we have to calculate this v square value. Okay. So then only we will get the total value. of the tensional force at the bottom. To find out this V square value, now we will apply the law of conservation of mechanical energy. Okay, so the law of conservation of mechanical energy, according to that, already we know this is the first equation, V square equal to R into G. Okay, so now, so I will take this is the second equation. Okay, so now here, according to law of conservation of mechanical energy, the total energy at this position is equal to the total energy at this position. Okay, so the total energy at this position equal to the total energy at this position. So now see here, at this position, if I will take, this is the ground state, it is the ground state, it is the H equal to 0, and from here to here the distance is the R. So this is the distance, here to here is the R and here to here is R. So the total distance from here to here to this object from this ground state is, the total distance is the 2R. 2R, because R is the radius, so from here to here is the capital R, here to here is also capital R. So the total distance is the 2R. So now what is the total energy at the top is equal to what is the total energy at the bottom. So here the initial potential energy plus initial kinetic energy equal to final potential energy plus final kinetic energy. So what is the initial potential energy? According to formula, this is the mgh and this is the of mvi square, initial velocity. And at this point, what is the final potential energy? Final potential energy, that is the 0, because h value equal to 0. So we can write this is the mghf and it is the I plus of mvf square. Okay, so hf value, this h value is equal to 0, so this total term will be 0. So we can write, this is the, I am writing here, v square equal to R into G. Okay, so this is the equal to 0. So mgh plus of mvi square equal to this total term will be 0 of mvf square. Okay, and what is the h value? This is the this object potential energy. So h value is the 2R. So mg into 2R. Okay, or you can first you strike out these m's on both sides. So gh plus of vi square plus, sorry, equal to of vf square. Okay, so now what we can write, g into h value 2R plus of v square is the R into g equal to of vf square. Okay, so now you can take this one. So 2gr plus of gr. So what we will take here, 4gr plus gr. So 5gr equal to vf square. Okay, that means 5gr by 2, vf square by 2, 2 will be cancelled. So we will get 5gr is equal to vf square. Okay, so now you can substitute this one in this equation. So substitute this one in this equation. So substitute equation 3 in equation 2. So substitute 3 in 2. Then what we can find out, TB equal to m by r, v square, e value is 5gr plus m into g. So this RR will be cancelled. 5 mg plus mg. So this is equal to 6 mg. So this is the tension at the bottom. Okay, so this is the tension at the tension of the string at the bottom. Okay, so to find out this tension of the string at the bottom, we have to take the law of conservation of mechanical energy. So that means the sum of the kinetic energy and potential energy at this position is equal to the sum of the kinetic energy and potential energy at this position. Okay, so this is the law of conservation of mechanical energy. Okay, thank you.